further examples. We are going to look at further examples in constant acceleration. Here in this example 2.4.1, it says that James practices using the stopwatch facility on his new watch by measuring the time between lampposts on a car journey. As the car speeds up, two consecutive times are 1.2 seconds and 1 second. That is, he resets his stopwatch at the lamppost 1. When it passes the first lamppost, it has spent 1.2 seconds, and then after when it reaches the third lamppost, another 1 second has passed. Later he finds out that the lampposts are 30 meters apart. So let's see the picture of this. Basically there are three lampposts, A, B and C, and then James actually resets his stopwatch at lamppost A, and then when it passes B, it seems that 1.2 seconds has passed, and then when the car passes the third lamppost C, 1 second has passed. Also later on he found out that the distance between lamppost A and B is 30 meters, B and C is also 30 meters. And let's see the question again. Calculate the acceleration of the car assumed constant and its speed at the first lamppost. Again, we don't know what is the speed at the first lamppost. What we know is it is accelerating at constant acceleration, and then the speed starting speed is not known, so we need to find the starting speed and the constant acceleration. Assuming the same acceleration, find the time the car took to travel the 30 meters before the first lamppost. So we want to find out how much time taken to travel 30 meters before it reaches the first lamppost, assuming same acceleration. So let's see the picture again. The diagram shows all the information, assuming acceleration is a meters per second squared, which is unknown, and the velocity at A is also unknown. It should be meters per second. Sorry, here it should be meters per second at the start of the at the first lamppost. And then we can apply for AB section. What we know is distance is 30 meters and the time taken is 1.2 seconds, and we don't know U and we don't know A, so we can use S equal to ut plus half at squared equation. So S equal to 30, U is equal to 1.2, sorry, T is equal to 1.2, U is unknown, plus half acceleration not known, T is 1.2 squared. So after simplification you get 30 is equal to 1.2 U, this is 1.2 squared divided by 2, 0.72a. And to use the same equation for the part BC, you would need the velocity at B. If you want to apply S equal to ut plus half at squared for the section B to C, then we need the velocity at B, which we don't know. So therefore we can apply S equal to ut plus half at squared from here up to here. So then we have a distance of 30 plus 30, 60 meters, and time of 1.2 second plus 1 second, 2.2 seconds. So that means therefore instead of using B to C, we apply, it is much better to go back to the beginning and consider the whole of AC, which is S equal to 60, T equal to 2.2. Then again using S equal to ut plus half at square equation, U is unknown, S equal to 60, T is equal to 2.2 is unknown, and T equal to 0.2 squared. So after simplification we get the second equation. These two simultaneous equations in two unknowns can be solved more easily if they are simplified. First, make the coefficients of U integers. That means you can use equation 1. Say equation 1 is 30, 1.2 U. So you can multiply by 10, divide by 12, you can get 1 here. So that's what we do here. So when you multiply equation 1 by 10, divide by 12, so you get the coefficient for U equal to 1. Similarly, you have to multiply 30 multiply by 10 divided by 12, we give 25, and then similarly we get the next coefficient 0.68. So please try and see. And then we can make the coefficient of equation 2 integer by multiplying by 5. So when you multiply by 5, 60 become 300, and then 2.2 will become 11. So 11u plus 12.1a. So then multiply equation 3 by 11, so you get 11u. Now let's subtract equation 5 from equation 4. Equation 5, we got 275 is equal to 11u plus 6.6a. So you substitute equation 5 from equation 4, which is 300 equal to 11u plus 12.1a. So 300 minus 275 is 25, 11u minus 11u 0, 12.1a minus 6.6a is 5.5a. So we got an equation only with the unknown a. We can find the unknown a by dividing 5.5 both sides. So a is equal to 4.545. So now we know the acceleration. Now we substitute the acceleration 4.545 for a in the equation 3. Equation 3, we have two variables u and a, two unknowns. So once you substitute for a, you can find the value of u, that is the initial velocity. So we can find u is equal to 25 minus 0.6 times the acceleration, which we get 22.273. So the answers are, the acceleration we already found. Acceleration of the car is 4.55 meters per second square, and the initial speed is 22.3 meters per second. That is correct for correct all three significant figures. These examples can be found in the book Cambridge International AS and A-Level Mathematics by Sophie Goldie, series editor Roger Procus, Howder Education. Thank you.